Good morning, good morning. I want to follow up on the previous video with a video on capturing the data to the computer from a Minolta FD-7. You don't see the Minolta FD-7 because it's in my hands, it's on my desk. So quickly let me launch this utility that's supplied free by my Minolta called FD-7W. So FD-7W, I launch it now on my screen. I don't know if they have a Mac version, they probably do, but you see here, this is what the interface of the application looks like when I launch it. So first thing I'm going to do is I'm going to hit the connect button. My instrument is already plugged in, so the connect button should be successful, and you see now it is successful. So I'm going to skip the calibration, although I could do that because it's not difficult, and I'm gonna hit it just to show you. I'm taking the calibration plate off, and I'm gonna place it under the instrument. You can hear the sound here, and I'm gonna hit it, the calibration button. It says please set the instrument on the white calibration plate, and I'm gonna depress the head and nothing happens, but I have to do that first and then hit the calibration button. And when I hit the calibration button, two things are happening. The light is flashing on the instrument once and then twice, and then if everything works, then we get this message that calibration was successful. So I'm going to take the calibration plate, place it back into its plastic bag, put it away so that the light doesn't shine on it, and I'm going to head now to the measurement settings. The measurement settings are where we select what we want to capture from the instrument. See the measurement type, there's reflectance and illuminance, because as you know, this instrument can measure in irradiance mode, meaning irradiance or illuminance. It can measure the light is incident on a surface. Measurement condition, this is very important. You see all the conditions that the instrument supports, M0, M1, M2, and I'm going to head on to M1, which I slowly have to get into the habit of using, because that's and ignore this but this message, it took me a while to figure what this meant. Observer is always 2 degrees, the 1931, and the illuminant is always D50. Otherwise we're not going to be able to use that much outside with inside of Photoshop or with ICC profiles, because that are all based on D50. Polarization is not our case. We don't have a polarization attached to the instrument, so we can skip that and click on OK. So now we specified the settings. The next thing we have to specify is the transfer items. That's actually what we want to capture, from the instrument. And you see here there's reflectance, we can capture all spectral data. Density is another possibility, and then there is general tab, smaller and larger. And what I have done here is I want to capture the date, but let me just get rid of all this. See, I'm pressing the left arrow, so I'm putting everything back here. So what I want the date, sorry, this button. I want the time, I want the measurement type, I want not necessarily the measurement type, the condition. I could get the condition, I'm not going to do that. Well, okay, let me get the condition. The white reference, I don't care. The observer, the illuminant, I don't care. The LEB is very important, but usually measuring applications for ICC, they always like to have the XYZ displayed and captured before the LEB. That's like a convention. And then L, and then A, and then B. If I needed the chroma or the U angle, I could use that as well. Unterlab is not really for me. If we want to have the staticity density, we could do that. We could do that as well. And you see there's also a few other things, such the density, that's not for me. I would stick with status T density either for the red, green, and blue, or just the visible, or all four, doesn't matter. And then I can have here what's called label that will appear at the top of each measurement. And then what we want here for the block separator, I haven't touched this yet, but you can see it's possible to do all kinds of crazy things. So once this is done, and I can move around, if I want the X to be going at the top, I can move it to the top, but I don't want it to show at the top. So I click OK, and then I'm ready to capture. You see, this is the serial number of the instrument, and the fact that this is green means that it's ready. So I'm gonna go to Excel and gonna make a new file, a new workbook. And now that I'm in Excel and I've created this new workbook, I am ready to capture. So let me go back to my P2P51, which I have it in my hand. I'm gonna place it on my desktop, and I'm going to be starting to measure the first patch at the top, and you see what happens. Now you see I haven't you see how fast this went. This is the measurement date, this is the measurement time. I'm increasing the column width in Excel because otherwise it's going to be too small, too cramped. And I'm going to select those 4 rows, and I'm going to center the data. So that would be patch number 1, and then I would add here number 1, number 2, number 3, or I could have this ready into a template, doesn't matter. And once I have this, I can extend it, and so on and so forth. So now I'm going to place the cursor on the second row, and I'm going to move off the instrument to the second patch. And as soon as I release it, you see the measurement appears. Now, the thing that is not very convenient is that the label keep appearing on top of every row. So that's not what I want. So I'll go back to the transfer item settings, and I'm going to turn off label over here. Click OK. Click back to Excel. I could delete those 4 rows, or I could just ignore them or leave them there. This would be the second row. So place the instrument back on the second patch, and that's it. Third patch. And you see now, it's very fast, by the way. Is it because my PC is fast, because I have a lot of RAM? I don't know, but it's going very fast. Now, let me show you what happens when I throw in spectral data. So I'm going to navigate to the spectral reflectance tab, and I'm going to select all spectral data, and I'm going to add that to the right. Click OK, go back to Excel. So now the next row, which would be the next patch, and that's the spectral data. And you see how fast that was captured? And there's a beep. As soon as I hear the beep from the instrument, I can release the head, move it off, and then be done with it. Now, I noticed that I don't have the label for the spectral data. I guess I could go back here, measure this first patch, and go back and activate the label. And this is the first patch. So I'm going to go back with the instrument, place it on the first patch, see what happens. There, you see, it gave me the first patch actually wasn't on the right place, so I'd have to do a bunch of undos. But the important thing is that you notice that now we have some identification for the spectral data, their wavelength. So we know this is the measurement at 390, 80 nanometer, and so on. And so if I want to go to the, let's say I want to measure, I want to get to the, just to give you an idea of what I usually do in Excel, I'm going to go to the cyan, 100 cyan patch. Okay, this is the 100 cyan, and this would be the 100 magenta, for instance. And this would be the 100 yellow. There it is. So now I need to plot this into a chart. So in order to do this into a chart, I need to have labels for the chart, but the labels are going to be without the nanometer characters, just 380, 390, 400, and so on. So let me just take those three and extend them all the way to 730 like this. So that will give me the x-axis. So I'm going to place the cursor over here, and I'm going to go to insert, and insert what? Insert a chart. This is the chart I'm going to insert. This is going to be an empty chart for now, and over here I'm going to now, with the right mouse button, go down to select data and hit the add button, and I'm going to call this cyan. And now the x value I'm going to select from here. These are the x value. So I'm going to go over the way to 730, go back, press this button. Now where would the y value be? So the y value are going to be below. The y value are partly hidden. Thank you very much. Nothing I can do about that. Boy, my bad. So I'm gonna select these y values and change them later, just to get this going. And this is the y value. Hit OK. Hit OK again. So now this should constitute this graph. You see, this is the graph. Now for the true y value, the true value are here: 55 minus 37 minus 36. See, the normal Gracal 2006 value would be 56 minus 37 and minus 50. That's their LEB, their usual LEB. So this ink on this paper is not that far off the ideal LEB value for Gracal 2006. It's just that this paper is not blue enough. It's too yellow. It's a solid bleach sulfate. I think that's what it's sulfate bleach, something like that. SBS, that's the acronym for. So I'm gonna edit, change this, go back to select data, and what I want is this value, this row here, 18. So I'm gonna select edit, and over here for the y value I'm going to tell it to use 18. Hopefully I don't get an error message, and click OK. So that's OK. So now let's see what the graph looks like. This looks better, and I'm going to edit the axis because it doesn't make sense that it starts at 0. So let me force it to start at 380. That's going to be a better use of our Excel real estate data, 730, and we want it to go, we want the y-axis to go also all the way to 10. So let me hit 1 over here, and that gives us a good cyan reflectance, spectral reflectance distribution. I could add now the magenta. I could change the color here. It's very nicely laid out, and I love capturing data into Excel. So I'm gonna stop now and see what I get into next. Thank you so much for your time and attention.